ladies and gentlemen.
Let's talk area and perimeter. So the perimeter of a 2D shape is the amount of total units around the outside of that shape, and the area is the number of square units or little tiny squares that we can use to completely cover the inside of the shape. So a lot of the typical shapes that we use have very common formulas, and we'll talk about each of those now. Rectangles and squares are very similar to each other. We've defined them previously, but the area of each is the length times the width. For a square, you could also have that the area is equal to the side length squared, where all of the side lengths are the same. So L times W, and L and W are the same, just square the number. Perimeter is 2 times L, because we have two L's, and 2 times W added together. So makes sense to go all the way around. Or for a square, the perimeter would be 4 times S. So makes sense. Moving on, we have parallelograms. So parallelograms are like rectangles, but tilted. So a lot of the same formulas. We have the perimeter, which is 2A plus 2B, makes sense going all the way around. And then the area is kind of like length times width, except for we need it to be at 90 degrees. We have that by default with a rectangle or a square, so we have to draw an altitude or a height for our parallelogram so it intersects at 90 degrees with one of the sides. And so it's the height times the side it intersects at 90 degrees. So we could also draw it this way, horizontally here. We just have to make sure that it hits at 90 degrees. Next up is triangles. Lots of different ways to visualize triangles, but they all have the same formulas. The perimeter is you add up all of the sides. Now, the sides could be the same depending on what type of triangle you have. If you have an equilateral triangle, for example, which is 3 times the side length. The area is the exact same as a parallelogram, just cut in half. So it's base times height divided by 2. Again, the height and the side that we're going to call the base needs to meet at 90 degrees. So it doesn't matter how it's drawn, but it does have to intersect at 90 degrees in order to use those two sides. And that side doesn't have to necessarily be called B, it's just typically that's what's used. But you divide it by 2, and the reason why is we can actually make a rectangle out of a triangle by kind of doubling it. And that also works for here. We could also double it this way, where if I double this part, I get this part, and I double this part, I get this part. So that is why the area is divided by 2 compared to a rectangle or parallelogram where you don't have to divide at all. So let's put that into action. Question 1. A rectangular area measuring 16 inches by 4 inches is to be tilled with 2-inch square tiles. How many tiles will be needed to cover the area? So first thing I'm going to do is I'm going to draw a picture. So we have a rectangle here that is 16 by 4, and we're kind of filling this with 2 by 2 squares. So it doesn't really look like a square. Let me try that again. So how many of these will we need? Well, we could just do it out and figure it out that way, but we can also use, our brains and save us a little bit of drawing here. So the area, the total area, is equal to 16 times 4, and 16 times 4 is 64, so we have 64 inches squared for the whole thing. As far as each square, so each tile, is going to be equal to 2 times 2, which is 4. Now, 4 inches squared. Now we can divide. 64 divided by 4 is, 16. So we're going to have 16 tiles in order to cover the entire area. Next up, what is the area of an equilateral triangle with a perimeter of 30 centimeters? So if we draw ourselves a little bit of a triangle here, we have a perimeter of 30, which means that each side length is going to be a third of that, which is 10. The area is base times height divided by 2. So we are essentially going to draw the height here. Now this may look familiar. We go back to our special right triangles. We know that this would be 5, and we can either use Pythagorean theorem or, again, our special right triangles to see that this is going to be 5 square root of 3. And in doing so, we would multiply the 5 square root of 3 by the whole base, which is 10. So we're going to do 10 times 5 square root of 3, and then we'll divide it by 2 for the area. Well, 10 divided by 2 is 5. 5 times 5 is 25, so we have 25 square root of 3 would be the area of this equilateral triangle. Last but not least, what is the area of the parallelogram shown? Well, to find the area, we need to do the base times the height, but we don't know what the base is. But they did give us that one base is 3x plus 5, and the other one is 4. And since they're across from each other in the parallelogram, that means they must be equal. So 4x is equal to 3x plus 5. So if we subtract 3x from both sides, we end up with x is equal to 5, which we're going to replug in, meaning that this base down here is 3 times 5 plus 5 is 20, and the height would be 6 times 5, and that would be 30. So the area is going to be equal to 30 times 20. 3 times 2 is 6 with 2 zeros, and that would be our area. Our area is 600 units squared. We don't know what the units are, so you could put units squared if you want to, but I'm going to leave them off for right now. And that is it when it comes to area and perimeter. Now we will be taking this a step further when we look at three-dimensional solids and circles and all of that, but for now, this is all you need to know. If you have any questions, please let me know. Otherwise, I look forward to seeing you in the next video.